If you are building with an AI right now, you know that the landscape is shifting fast. We used to just connect app A to app B. That was simple. But now we have autonomous agents, massive language models with limited memory, and a universe of external tools. Suddenly, just building an API isn't enough to manage this chaos. You start hearing new acronyms thrown around like ACP and MCP alongside the traditional API thing. Are they competitors or do you choose just one? The answer is no. They are puzzle pieces in the modern AI architecture. In this video, we are going to demystify API, Agent Communication Protocol or ACP, and Model Context Protocol or MCP. We'll define them, look at the diagrams, and finally show how they work in perfect sync to build powerful AI systems. So let's get started. Think of an API as a very strict contract. The client app says, I need X data in exactly this format, and the server says, here's the data in exactly the format that was requested by the client. It's a rigid, predictable pipe. In AI world, APIs are still crucial. They are the arms and legs of your AI. When ChatGPT writes code and executes it, it's using an API. When an AI agent searches Google or adds a row to your spreadsheet, it is doing that by using an API. The crucial point here is that APIs are for execution. They don't think, they just do exactly what they are told to do. But what happens when you move beyond a single AI model answering a question? What if you have a team of agents trying to solve a complex problem together? If you use standard APIs, Agent A has to command Agent B. But what if Agent B disagrees or needs clarification? Standard APIs aren't built for negotiation. That's where ACP or Agent Communication Protocol comes in. Look at this diagram. We have a planning agent, a coder, a researcher. They aren't just sending data, they are talking. The lines here are dashed to represent conversational flow, not just data pipes. ACP defines the language they use to communicate their intent, their status, and their needs. If the planner asks the coder to build something, the coder might use ACP to say, I can do that, but first I need the researcher to find this specific library documentation. ACP allows autonomous entities to collaborate together towards a shared goal. It's the conference room table for AI agents. So we have APIs for action, ACP for team coordination. What's missing? The biggest bottleneck is modern AI or the context window. LLMs like ChatGPT or Claude are brilliant, but they have limited short term memory. If you dump your entire company's database into their prompt, they crash or they get confused. You need a way to feed the brain only the information it needs, right when it needs it. This is MCP, Model Context Protocol. On the left of this diagram, you have vast amount of messy data, databases, files, vector stores, and different sort of data source. On the right, the LLM brain with its limited context window. MCP sits in the middle. It provides a standardized way for the model to ask, hey, I'm working on this specific problem. What data do you have that is relevant? MCP doesn't dump data. It formats it, summarizes it, and selects only the critical pieces to inject into the brain, ensuring that the model is smart without being overwhelmed. MCP manages knowledge flow into the model's limited attention span. Okay, we have defined them separately. Now here is the payoff. How do they work in sync? Let's imagine a complex scenario. You tell an AI system, plan a 3-day business trip to Seattle for me. Book flights under $500 and find hotels near the convention center. A single API can't do this. A single LLM prompt isn't enough. You need a full stack. Here is the symphony in action. Here you can see in the diagram how everything works in coordination. First, the trigger. You, the user, sends a request to the main travel agent. Second, we use ACP for coordination, which is represented in dashed lines. The travel agent realizes this is too big for one brain to handle. It uses ACP to negotiate with a flight agent and a hotel agent, and it will start delegating tasks. Then we have MCP for context. Before searching, The flight agent needs to know your sitting preferences, and the hotel agent needs to know your loyalty numbers. They don't have this in their intermediate memory. They use MCP to query your personal profile database and pull only that is relevant context into their LLM brains. And then we have APIs for execution. Now, armed with the plan and the context, the flight agent uses a standard airline API to check real prices. The hotel agent uses a booking API. And finally, they report back via ACP. The main agent compiles the plan and presents it to you. That's the modern AI stack. Don't think of it as API versus ACP versus MCP. Think of them as layers of capability. API is the muscle, it executes action in the real world. ACP is the voice, it lets agents coordinate and plan together. MCP is the memory gateway, it ensures that the AI has the right context at the right time. As you build more complex systems, you'll likely stop just building APIs and start architecting ecosystems using all three protocols. If you would like to know more about APIs, you can watch this video of mine which explains APIs in detail. And if you would want me to create a video explaining in detail ACP and MCP protocols, let me know in the comments. Thank you.